Hello. We're going to talk about a certain type of problem which can sometimes be confusing. Usually it gives you some sort of equation that you cannot solve and still asks you to answer a problem. This is an example of that kind of question. It says, consider the equation 4x plus 8y equals 33. Is there a solution such that x and y are both positive integers? Well, your first instinct may be to try to solve this problem, or solve the equation. And you see here that if you try to solve for x, or if you try to solve for y, it's just going to end up giving you something that's not helpful. See, we still have a variable here that we don't know. So, in other words, we can't solve this equation. Well, the good thing is that they're not asking you to solve the equation. They're asking you if there is a solution possible when x and y are positive integers. The way you solve this kind of problem first is that you need to recognize that you can factor this equation, or the left side of the equation, and if you pull a 4 out of both the x and y terms, that gives you 4 times x plus 2y equals 33. So now you can divide through both sides by 4. That cancels out. And that leaves you with x plus 2y equals 33 over 4. Now, you know that 4 doesn't go into 33 evenly. It's going to give you something like 8 point whatever. A bunch of decimal places here, right? So basically what this is saying is that if you had a positive integer x, any positive integer, and you added that to 2 times any positive integer y, is it possible that that could give you a number with a lot of decimal places? Or in other words, a non-whole number, a non-integer. And of course you should recognize that no, it's not possible. Here are a couple of examples. I'm going to make an x and y table here. For the first one, let's let x equal 2 and y equal 4. These are both positive integers, right? If we plug 2 in for x, that gives us 2 plus 2, and plug 4 in for y. And we evaluate that. That's going to give us 2 plus 8, which is equal to 10. Well, 10 is a whole number. You know, there's no integers on there. Here's another example. We'll use 3 and 3. That'll give us 3 plus 2 times 3, which is the same thing as 3 plus 6, which is 9. If we use 4 and 5, that gives us 4 plus 2 times 5, which is equal to 4 plus 10, which is equal to 14. You see, we could do this for any positive integer, and these numbers over here would always be whole numbers. We would never get any decimal places, like we would expect from what we did up here. So the answer to this question is no. There is no way that you could choose x and y to be positive integers and solve this equation.